So you're wondering why two-stroke and four-stroke engines are so fundamentally different. Here's the thing, these two engine types are like siblings who couldn't be more opposite if they tried. One's the wild child that screams at 8,000 RPM while guzzling fuel like a college freshman at a kegger. The other's the responsible adult who shows up to work on time and gets 40 miles per gallon. But here's what'll blow your mind. The dirty two-stroke engine that everyone loves to hate actually powered some of the most revolutionary moments in human history. However, there's a dark secret the EPA doesn't want you to know. Many two-strokes can actually be cleaner than many four-strokes on the water today. The real controversy: we might have banned the wrong technology. Let me paint you a picture that'll stick with you forever. Imagine your engine is like your lungs. A four-stroke engine breathes like you do. Inhale, pause, exhale, pause. Nice and steady. A two-stroke? It's hyperventilating, breathing in and out simultaneously like it just ran a marathon. And that fundamental difference in how these engines breathe creates a cascade of consequences that'll absolutely fascinate you. Here's the technical breakdown that'll make you the smartest person at your next barbecue. A four-stroke engine completes its power cycle in 4 movements of the piston. That's 2 complete revolutions of the crankshaft. We're talking intake stroke, suck, compression stroke, squeeze, power stroke, bang, and exhaust stroke, blow. Each stroke has its own dedicated purpose, like a well-choreographed dance. The four-stroke uses valves, typically 2 intake and 2 exhaust, controlled by a camshaft that's precisely timed to the crankshaft rotation. This valve train is what makes four-strokes more complex, but also more efficient at controlling exactly when fuel enters and exhaust leaves. Modern four-strokes often feature variable valve timing, allowing the engine to optimize performance across different RPM ranges. A two-stroke? This bad boy gets the whole job done in just 2 piston movements, 1 revolution of the crankshaft. It combines intake and exhaust into 1 stroke, and compression and power into another. It's doing twice the work in half the time, which is why your neighbor's leaf blower sounds like it's about to achieve liftoff. But here's the clever bit. Two-strokes use ports cut into the cylinder walls instead of valves. As the piston moves up and down, it covers and uncovers these ports, controlling the flow of fuel in and exhaust out. The crankcase acts as a pump, pressurizing the fuel-air mixture before it enters the cylinder. This port timing is critical. Get it wrong and you're either losing power or burning holes in pistons. Now, before we dive deeper into this mechanical rabbit hole, here's something that'll make you hit that subscribe button faster than a two-stroke acceleration. By the end of this video, you'll understand why your grandpa's old Mercury outboard could outrun modern four-strokes twice its size, and why that same technology might be making a shocking comeback. Plus, I'll reveal the one maintenance trick that can double your engine's lifespan, whether it's two-stroke or four-stroke. So smash that subscribe button and ring the notification bell, because we're about to get our hands dirty with some serious engine knowledge. Let's rewind to 1878, when a Scottish engineer named Dougald Clerk looked at the four-stroke engine, invented just 2 years earlier, and thought, this is taking too long. He invented the first two-stroke engine, and suddenly power-to-weight ratio became the name of the game. The early days were wild. Two-strokes dominated everything from motorcycles to chainsaws, from outboard motors to even cars. Yes, cars, the famous Saab 96 rally car that dominated winter rallies in the 1960s, two-stroke powered. East Germany's Trabant, two-stroke. These engines were everywhere because they were simple, powerful, and cheap to manufacture. But here's where it gets juicy. The four-stroke engine, invented by Nikolaus Otto in 1876, was initially seen as overly complex. Why have valves, camshafts, and timing chains when you could use simple ports in the cylinder? The four-stroke was the engineer's engine, sophisticated but complicated. The marine industry particularly fell in love with two-strokes. By the 1950s, companies like Mercury, Johnson, and Evinrude were pumping out two-stroke outboards that transformed recreational boating. These engines were light enough for one person to carry, but powerful enough to get a boat on plane. A typical 100-horsepower two-stroke from the 1960s weighed about what a modern 40 to 50-horsepower four-stroke weighs today. Think about that for a second. Now here's where our story takes a controversial turn. The 1970s brought the Environmental Protection Agency, and suddenly those blue clouds of two-stroke smoke became public enemy number one. The EPA looked at two-strokes and saw a problem. These engines were dumping up to 30% of their fuel unburned into the exhaust. But wait, here's the kicker that nobody talks about. The EPA's testing methods were designed for automotive designs, not marine applications. They measured emissions at idle and low speeds, where two-strokes are notoriously inefficient. At wide-open throttle, where boats actually operate most of the time, modern two-strokes with direct injection can be remarkably clean. Some argue the EPA threw the baby out with the bathwater. The 1990s saw the writing on the wall. The EPA announced that by 2006, marine engines would need to reduce emissions by 75%. For traditional carbureted two-strokes, this was essentially a death sentence. Manufacturers scrambled to develop four-stroke outboards, which had barely existed in the marine world before. What followed was nothing short of an engineering exodus. Major manufacturers either abandoned two-strokes entirely or poured millions into developing direct injection two-strokes that could meet emission standards. Yamaha went all in on four-strokes. Mercury developed Optimax. Evinrude created E-Tech. The bans started rolling in. California led the charge, banning the sale of new carbureted two-stroke outboards. Lake Tahoe banned them entirely from its pristine waters. Europe followed suit with increasingly strict emissions standards. By 2010, buying a new carbureted two-stroke outboard in many places was like trying to buy a new cassette player. Technically possible, but why would you? But here's the controversial part. While we were busy banning two-stroke outboards, nobody seemed to notice that lawn equipment, which operates right next to our faces, continued using the same technology. Studies have shown that a typical two-stroke leaf blower can emit as much pollution in 1 hour as driving a modern car for hundreds of miles. Yet you can still buy one at any hardware store. Makes you think, doesn't it? Let's talk money, because that's what really matters when you're standing at the marine dealer with your wallet open. A modern four-stroke outboard costs roughly 20 to 30% more than an equivalent two-stroke did in its heyday, but that's just the beginning. Weight is the hidden cost nobody mentions. A 200 HP four-stroke outboard weighs around 500 pounds. The old two-stroke version, about 375 pounds. That extra 125 pounds hanging off your transom affects everything. Performance, fuel economy, handling, and even the structural integrity of older boats not designed for that weight. Here's a maintenance reality check that might surprise you. Four-strokes aren't necessarily cheaper to maintain. Sure, you're not mixing oil with fuel anymore, saving about $50 to $100 per season for the average boater, but four-strokes require oil changes every 100 hours, which runs $150 to $300 each time at a dealer. They need valve adjustments every 200 to 400 hours, costing $400 to $800. Their more complex cooling systems are prone to corrosion, and timing belts or chains eventually need replacement at $1,000 or more. Meanwhile, a traditional two-strokes maintenance consisted of spark plugs, lower unit oil, and making sure you mix the right amount of oil in your fuel. My uncle ran a 1985 Mercury 150 two-stroke for 35 years with nothing but basic maintenance. Try that with a modern four-stroke. The oil mixing debate deserves its own moment here. Old-timers swear by 50-to-1 ratios, while manufacturers often recommended 100-to-1 for newer engines. Here's what they didn't tell you. Oil quality matters more than ratio. Modern TCW3 rated oils are engineered to protect at leaner ratios, but running slightly rich, like 80-to-1 instead of 100-to-1, provides extra insurance and doesn't significantly impact performance or emissions in real-world use. Another maintenance factor nobody talks about: salt. Marine engines face brutal conditions, and two-strokes had an advantage here. Their constant oil bath provided natural corrosion protection. Four-strokes, with their precise tolerances and complex valve trains, are more susceptible to corrosion damage. A four-stroke that isn't properly flushed after saltwater use can suffer catastrophic damage in a single season. Two-strokes were more forgiving of owner neglect. Not ideal, but realistic for how many people actually maintain their equipment. But here's the maintenance secret I promised earlier, the one trick that doubles engine life. Run your engine at varied speeds. Both two-strokes and four-strokes suffer from carbon buildup when run at constant RPMs. Vary your speed every 10 to 15 minutes, occasionally running at wide-open throttle after proper warm-up, and you'll burn out carbon deposits that kill most engines prematurely. This single habit has kept commercial fishermen's engines running for thousands of hours. Now, you might be wondering where all this technology stands today, and I promise you, the answer is going to surprise you. In fact, what's happening right now in the two-stroke world might completely change your mind about which engine type is actually better. But first, if you're finding this deep dive into engine technology as fascinating as I am, do me a favor and hit that like button. It tells YouTube that people actually want to learn about real mechanical knowledge, not just watch another top 10 list. And if you want to be the first to know about the revolutionary new engine technology that's about to flip this entire debate on its head, make sure you're subscribed with notifications on. Here's where things get really interesting. While America was busy falling in love with four-strokes, the rest of the world kept innovating with two-strokes. Modern direct injection two-strokes from manufacturers like Evinrude, before they stopped production in 2020, and Mercury's Optimax are technological marvels that would make those old smoke-belching engines weep with envy. These aren't your grandpa's two-strokes. Direct injection means fuel is sprayed directly into the combustion chamber after the exhaust port closes, eliminating the fuel loss that made old two-strokes so dirty. Electronic control modules optimize injection timing and oil delivery. Some modern two-strokes actually produce fewer emissions than four-strokes while maintaining that characteristic two-stroke power-to-weight advantage. Here's how direct injection revolutionized two-strokes. Instead of mixing fuel with air in the crankcase, where up to 30% could escape out the exhaust port, DI systems inject fuel at up to 600 psi directly into the combustion chamber. The timing is computer-controlled to the millisecond. Mercury's Optimax uses an air compressor to create a stratified charge. Rich mixture near the spark plug, lean mixture elsewhere. This gives diesel-like fuel efficiency with gasoline power. Evinrude Z-Tech took a different approach, using voice coil fuel injectors similar to high-end stereo speakers. These injectors could pulse multiple times per combustion event, tailoring the fuel delivery to exact conditions. The result? Two-stroke engines that met the same emission standards as four-strokes while being 15 to 20% lighter and producing more torque. BRP Z-Tech G2 engines, before production ended, were achieving fuel economy that matched or beat similar four-strokes. They had extended maintenance intervals with no scheduled dealer maintenance for the first 3 years or 300 hours of operation. No break-in period, minimal service requirements. Meanwhile, four-stroke owners were visiting their dealers every season for oil changes and inspections. The dirt bike world never gave up on two-strokes. KTM, Husqvarna, and others continue developing cutting-edge two-stroke technology. Transfer port injection, TPI, and throttle body injection, TBI systems have created two-strokes that pass Euro 5 emission standards, some of the strictest in the world. These bikes are proof that two-stroke technology isn't dead, it just needed better engineering. Let's address what every speed lover wants to know, which is actually faster. On paper, 4-stroke wins. A modern 300 horsepower 4-stroke makes its rated power consistently and smoothly, but horsepower doesn't tell the whole story. 2-strokes make power differently. They produce a power pulse every revolution instead of every other revolution. This means more power impulses per minute, creating that characteristic 2-stroke hit that makes them feel faster than their horsepower suggests. A 200 horsepower 2-stroke often feels stronger than a 250 horsepower 4-stroke in real-world acceleration. Here's a dirty little secret from the racing world. When equally prepped and weight-adjusted, 2-strokes are still faster in many applications. That's why you'll still see 2-stroke classes in boat racing, motocross, and snowmobile racing. The power-to-weight ratio is simply unbeatable. But 4-strokes have their advantages. Torque curves are broader, making them easier to drive. They're quieter, smoother, and more refined. For cruising, trolling, or any application where smoothness matters more than power to weight, 4-strokes are superior. They're also more fuel-efficient at part throttle, where most of us actually operate. Let's talk about specific applications. Bass fishing, 4-stroke all day. You need that quiet idle for sneaking up on fish, and the instant throttle response for jumping on plane in shallow water. The broad torque curve helps when you're loaded with gear and a live well full of water. Offshore fishing. Many prefer 4-strokes for the fuel efficiency on long runs and the smooth idle when trolling. But switch to flats fishing in skinny water and suddenly weight matters more. A lightweight 2-stroke lets you pole across flats that would ground a heavier 4-stroke setup. Racing, forget about it. 2-strokes dominate. The power-to-weight ratio is unbeatable, and when you're rebuilding engines between races anyway, longevity isn't the priority. Commercial operators tell an interesting story. Many crabbers and gill netters still run ancient 2-strokes because they're field repairable. Blow a power head, swap it in an afternoon. Try that with a modern 4-strokes complex valve train. When your livelihood depends on being on the water, simplicity trumps efficiency. Now here's where I'm going to blow your mind one more time. The future might not belong to either traditional 2-strokes or 4-strokes. Emerging technologies are beginning to blur the lines between these two designs. Advanced valve timing systems in 4-strokes are allowing more flexible operation. New combustion technologies are creating more efficient burn patterns. Some experimental engines use opposed pistons or other novel configurations that challenge our traditional definitions. But the real game changer might be the return of the 2-stroke in hybrid applications. Electric motors can compensate for a 2-stroke's weak low-end torque, while the 2-stroke provides lightweight range extension. Several automotive manufacturers have researched range extender 2-strokes, and marine manufacturers are quietly developing hybrid 2-stroke systems. Here's my prediction, and you can quote me on this. In the coming years, we'll likely see production vehicles using advanced 2-stroke engines as range extenders for electric drivetrains. The simplicity, power density, and manufacturing cost advantages of 2-strokes make them perfect for this application. We went full circle, from 2-strokes being too dirty to survive, to potentially being the solution for clean transportation. The controversy continues in the recreational world. As regulations tighten on 4-stroke emissions, yes, they're coming for 4-strokes too, manufacturers are hitting walls with technology and cost. Meanwhile, modern 2-stroke technology sits on the shelf, proven but largely unused due to market perception and regulatory framework that hasn't caught up with technology. So which is better, 2-stroke or 4-stroke? After diving deep into these technologies, here's the truth. We're asking the wrong question. The real question is, which is better for your specific application? Need lightweight power for racing? Modern direct injection 2-strokes are unbeatable. Want smooth, quiet cruising? 4-strokes excel. Strict emissions area? 4-stroke is your only choice for now. The tragedy is that in our rush to clean up emissions, we may have abandoned a technology that just needed better engineering. Modern two-strokes prove the technology wasn't the problem, the implementation was. This story is really about innovation versus regulation, perception versus reality. Your four-stroke outboard exists because regulations force the market's hand. If you run a modern direct injection two-stroke, you're operating technology that represents what could have been. The next time someone calls two-strokes dead technology, remind them that their simplicity and power density are too valuable to ignore forever. Whether it's in hybrid applications or specialized uses, the two-stroke principle isn't going anywhere. What's your take on this eternal debate? Are you team two-stroke or team four-stroke? Drop your stories in the comments below. If you found this deep dive valuable, smash that subscribe button and hit the bell. Next week I'm revealing the secret engine technology that switches between two-stroke and four-stroke operation on demand. It's already been built and tested. Share this with that buddy who swears by their old two-stroke or just bought a new four-stroke. Let's keep this conversation going, because understanding our machines makes us all better operators. Until next time, keep those props spinning true.